I'm Steve Gagne from Lockheed Martin, and I'm here at the NextFlex Flexible Hybrid Electronics Conference. And I have a booth about one of our applications for the flexible hybrid electronics, in particular for the printed electronics on three-dimensional surfaces. So this is a UAV aircraft or an SUAV, so unmanned aerial vehicle, or a small unmanned aerial system. And this is a Desert Hawk aircraft that Lockheed Martin fabricates. We sell to the Army. It's a soldier portable aircraft. It actually comes apart in 7 pieces, and there's a case behind here. It packs in the case and can be field deployable. And the soldier actually will launch this by hand, and it flies ISR missions, which is intelligence, surveillance, reconnaissance. And normally there's a little gimbaled camera that fits underneath here that's taking pictures as it's flying. It's relaying the video feed to the operator, who has a hand-controlled unit to see all the video feed and to record it, so it can either operate by remote control or autonomously. So it has a lot of capabilities, and this is the avionics bay. But one of the capabilities it doesn't have, because it's too small, it doesn't have a satellite communications. So that's one of the applications that we thought we could use. And a normal ComSat antenna is usually a big, large disc that's gimbaled. It's a lot of weight. It impacts the weight of the aircraft, the aerodynamics of the aircraft, the center of gravity. So we thought if we could print a phased array antenna. So this is the printed portion. And there's a video here that actually shows the machine that's printing it. So we have a 5-axis printing machine at Lockheed Martin, and we printed this, this phased array antenna. So it's a 16-element phased array antenna. And eventually we're going to have some phase shifters here so that we can do electronic beam steering. So for, say, like a satellite application, where as this is flying and it's twisting and turning and banking, the antenna can keep steered on the satellite, so we can maintain our data link with the satellite. Now it's a little difficult because this is not a flat surface. It's a concave surface, or a convex surface. So we use these printers, these 5-axis printers, to be able to print this over 3-dimensional surfaces or conformal type of surfaces, and that way we don't have to add extra antenna elements to do this. And we can tie the cabling into our existing electronics to control the beam steering. And now this was printed with a nano ink. So this is a copper nano ink. So it's an ink with little nano-sized particles in there. And one of the advantages of that is when you print it, you can go through a laser sintering operation, and it sinters all the nanoparticles together, so it's more like a solid sheet of copper. So the printing allows us the versatility to design the pattern and to print it on 3-dimensional surfaces, but then we can sinter it and get the performance of like a solid copper. So this is one of our applications. We're hoping to demonstrate it on our Desert Hawk aircraft and then transfer that technology to other UAV aircrafts that Lockheed Martin has. All right, one of the other applications that we have is a spiral antenna. So this is a dual-armed Archimedes type of spiral. We use it in our products. And typically it's used in pairs, but what we're doing is we're putting like a sawtooth or a tooth structure to it. So instead of a flat spiral that just spirals around, kind of what's shown here in the interior where it's actually printed, but now we have like a 3-dimensional type of trace. So it goes through this zigzag pattern instead of a flat pattern. So you have, for the same size spiral, and the spiral geometry determines the frequency band. So for the same frequency band, you have a physically longer path length. And I guess the best way, simplest way to think about that is that longer path length for the same spiral gives you more gain. So you get more sensitivity to the antenna, you can detect things at longer range, and you get a lot of performance benefit for basically the same size antenna by using the third dimension. And the only way that we can actually print something like this is using one of these machines. You need a machine that's able to print up and down this zigzag and be able to print this pattern, which is actually very challenging because of the fine features involved. But we're using the NextFlex techniques and the machines to make products like this, which will enhance our product line that we ultimately sell to the government and the DoD. So that's what we're doing, and thank you.